Okay, so this video is called the rocket car, and it's designed to develop a better understanding of acceleration for you. When you finish watching this video, you should be able to distinguish between acceleration, velocity, and position. You should be able to predict if an object is speeding up or slowing down, and you should be able to determine the direction of motion of an object and distinguish that from the direction of its acceleration. So let's get started by looking at a rocket car. So here's the car right here. Here's its rocket engine with the flame shooting out the back there. And that rocket engine gives it a particular push in this direction. And that push gives it an acceleration of 5 meters per second per second. So I'm just making up that number, 5 meters per second, as a number to work with in this particular story. And what I want to do is examine what does this 5 meters per second mean. So let me rewrite it over here, 5 meters per second. Okay, so this is the velocity. And in that term 5 meters per second, this tells us, everything in the circle there tells us by how much the velocity changes. Okay, so this tells us how much velocity changes each second. Another way to look at that is to say that this number right here, the 5, make that a different color. The 5 tells us how much the speed changes, and the sign out here, which in this case is positive but could be negative, tells us in what direction the speed changes. So together, of course, that makes up how much the velocity changes each second, because velocity is speed and direction. All right, let's switch back over to the black marker, and we'll make a little chart here. Acceleration, time, and velocity. And we'll start at time 0. 1, 2, 3, 4, 5, 6, 7, 8. We'll go up to 8 seconds. What I want to do is examine what happens to the velocity here as the car is moving along with that particular acceleration. And let me get this stuff out of here. Shrink that up and put that over here. All right, now let's come over here and take a look at what happens to the velocity. So, if the car has an acceleration of 5 meters per second, then each second its velocity changes by 5 meters per second. And therefore, at time 0, its velocity is 0, even if its acceleration is 5 meters per second, because time hasn't started yet. That acceleration has not had an opportunity to change the velocity of the car. But after 1 second, the car is going 5 meters per second. All right, after 2 seconds, how fast is the car going? If you said 10 meters per second, you're correct. And after 3 seconds, how fast will the car be going? If you said 15 meters per second, you're correct. And of course, these are all positive, so the velocity of the car goes from 0 to 5 to 10 to 15. Now, if these were speedometer readings in your car, you would clearly say, hey, I'm going faster or I'm speeding up. And so that's the way to think about the number here. The sign, the inherent plus sign that's here, even though we don't always write that down, tells us what direction we're going. It's more like a compass. Now, at 3 seconds, let's make 5 be here, but at 3 seconds, the very end of that 3-second interval, the acceleration is going to switch to -5. How does that happen? Well, let's go back to our car,